Welcome to Metrology lecture series. In the present video, we will discuss the standard limit system. First, we will discuss the need of the limit systems should be standard. With the rapid growth of national and international trade, it has become essential to establish formal systems of limits and the fits. These standards ensure that products made in different places fit and function correctly. So wherever the products are manufactured, they will be fit and function correctly due to the standardization of the limits and the fits. In this regard, every country has its own standards for engineering limits and the fits, but in order to have universal interchangeability, it is essential to follow a uniform standard throughout the world. In this regard, we are following the three standard limit systems. First one is the British standard, that is BS. Second one is the International Standard, ISO. Third one is the Indian Standard, IS. All these three standards basically make to use of the following standard tolerance and the fundamental deviation. First, we have to discuss about the standard tolerance. Indian standard system, that is IS, follows the guidelines and recommendations given by the ISO, that is International Organization for the Standardization, and the Indian standard system IS 919 covers the sizes up to the 500 mm and IS 2101 covers the sizes from the 500 to 3150 mm. And in the IS 919 is a combination of 18 grades of fundamental tolerances and the 25 types of the fundamental deviations. And the tolerances are the designated by the capital letters IT and followed by a number. For example, IT 16. So IT is the fundamental tolerance. 16 is its tolerance value. And the ISO system provides the tolerance grades from the IT01, IT0 and IT1, IT2 up to the IT16. So we know that one. So we have the 18 grades of the fundamental tolerances, that is IT01, IT0 and IT1, IT2, IT3 up to the IT16. And moreover, here to observe, the greater the number, the higher the tolerance limit, and this tolerance value is the guided by the functional requirements. So based on the requirements, its tolerance value it will be changes. Let's see the following table. Various tolerance values are the required for the various applications. So there is the IT01 to IT4 is for applications of the production of gauges and the plug gauges and the measuring instrument. And IT5 to IT7 is for the applications of fits in precision engineering applications such as the ball bearings, grinding, fine boring, high quality turning and the broaching. And IT8 to IT11 is for general engineering, that is turning, boring, milling, planing, rolling, extrusion, drilling and precision tube drawing applications. Moreover, IT12 to IT14 is for the sheet metal working or maybe press working applications. And finally, IT15 to IT16 is for the process such as the casting, stamping, rubber molding, general cutting work and the flame cutting applications. And these tolerance values, especially for the grades IT5 to IT16, are determined using the standard tolerance unit, that is small I, which is the function of the basic size. So small I which is the standard tolerance unit, equal to the 0.45 into cubic root of capital D plus 0.001 into capital D, and here I values are in the microns, and capital D is the diameter of the part in mm, and moreover by using this formula, tolerance unit small I is obtained for sizes up to the 500 mm. So this tolerance unit, so formula is applicable up to the sizes of 500 mm. And capital D is the geometric mean of the lower and upper diameters of a particular diameter step is calculated by using the following equation, that is capital D equal to the root of D max into D minimum. So here capital D is the diameter of the part, but directly we should not to take the D value. It is the geometric mean of the lower and upper diameters of the step diameter. This lower and upper diameter values are the given by the IS 919, and the ranges are the following ranges. So here especially we should have to remember 10 to 18 step range, 18 to 30 step range, 30 to 50, 50 to 80, and 80 to 120, 120 to 180. So these are the ranges we should have to remember. So next we have to look for the values of tolerances for the tolerance grades IT5 to IT16, which are given in the following table. So IT5 value is the 7i, IT6 value is the 10i, IT7 is the 16i, IT8 is the 25i, IT9 is the 40i, IT10 is the 64i, and IT11 is the 100i, for IT12 160i, for IT13 250i, IT14 400i, for IT15 640i, IT16 1000i. See here, so tolerance values, we know that tolerance value is representing in the small I, and depend upon the application its value also changes. So IT5, IT6 up to the IT16 is the for the different applications. For the different applications tolerance value also changes. Here at least we should have to remember, so IT7, IT8, IT9, IT10 and IT11 we should have to remember. And moreover for the tolerances IT01 to IT5 are the tolerances in microns are the calculated as below. So for the IT01 tolerance value equal to the 0.3 plus 0.08 into the capital D. Similarly for the IT0 tolerance value equal to the 0.5 plus 0.12 into capital D. For the IT1 tolerance value is the 0.8 plus 0.02 into capital D. Here capital D is the in mm, and the values of the IT2 and IT4 are regularly scaled approximately geometrically between the values of IT1 and IT5. Next we will discuss the fundamental deviations. We know that in the IS system we are having the 25 types of the fundamental deviations, and these fundamental deviations are the represented by the letter symbols for the both of the hole and the shaft. And capital letters, that is capital A to ZC, is representing for the fundamental deviation of the holes, and small letters small a to ZC are the representing the fundamental deviation for the shaft. So in the schematic you have to observe that one it is the representation of the different types of fundamental deviation for the holes as well as for the shaft. So first we have to observe for the holes. So we know that one for the hole. So fundamental deviations are the represented by the capital letters, capital A to so ZC. So these are all the 25 types of the fundamental deviations are the varying with respect to the basic size. Similarly, we have to observe the below diagram. So by observing the diagram B, so this is the fundamental deviations for the shaft. Here observe the fundamental deviations, that is small a to ZC for the shaft. It is varying with respect to the zero line. And different combinations of the fundamental deviations and fundamental tolerances are used to obtain the various types of the fits. So depend upon the type of the fit, we should have to choose the different combinations of the deviations as well as the fundamental tolerances. So moreover, I have to observe for the schematic representation of the fundamental deviations for the hole and the shaft. For the holes, capital A to capital H. So this lower deviation is above the zero line, and for the hole, capital J to capital ZC, it is the below the zero line. So in the schematic you have to observe that here lower deviation. What is the meaning of the lower deviation? It is the difference between the lower limit of the size and basic size. So it is the basic size, zero line is the basic size, and this is the lower limit. So here observe the for the holes, from the capital A hole to capital H hole, here lower deviation is above the zero line. So it is the above the zero line, and the capital J hole to capital ZC, this lower deviation is the, so this is the lower deviation, it is the below the zero line. Similarly, observe the schematic representation of the fundamental deviation of the shaft. For the shaft, small a to small h, upper deviation is the below the zero line, and for the shaft, small j to ZC, it is the above the zero line. So here observe. So upper deviation, what is the meaning of the upper deviation? Upper limit of the part minus basic size. So this is the upper deviation. How the upper deviation is there? For the shaft, A to H, small a to small h shafts, this upper deviation is below the zero line. And similarly observe, so shaft J to ZC, this upper deviation is the above the zero line. And moreover, here to observe for the holes A to G, lower deviation, that is EI, is a positive fundamental deviation, and its value is the EI equal to ES minus IT. And for the holes capital K to ZC, the fundamental deviation ES, so that is upper deviation is the negative, and relation is the ES equal to EI minus IT. Similarly, for the shaft small a to G, fundamental deviation ES, that is the upper deviation is the fundamental deviation, and ES is the negative value, and ES equal to EI minus IT. And moreover, for the shaft small k to ZC, the fundamental deviation is the lower deviation, and that is the EI is value is the positive, and EI equal to ES minus IT. Moreover, by observing the schematic representation of these fundamental deviations, here for the shaft as well as the hole of the J, and deviation is equal to the plus or minus IT by 2, which means for the shaft J and the hole J, this deviation is varying equally above and below the zero line. So next we have to look for the how to give the designation of the hole, shaft and the fits. For the hole and the shaft, it's completely described by the basic size and followed by the letter, that is the deviation, and the number, that is the tolerance grade. For example, so how to represent the hole mean, let's consider the basic size is the 50 mm and the H type of the hole with the tolerance grade of the IT7. So this is we can be written as 50 H7. So 50 is the basic size. Here capital H. So capital letters for the hole. So H type of the fundamental deviation and 7 is the tolerance grade value. Its value is the IT7. Similarly, a 50 mm of a F shaft. Shaft is the F type of the shaft with the tolerance grade is the IT8. So this is we are representing the 50 F8. So 50 is the basic size and for the shaft we have to write down the small letters. So F is the deviation is the F type and 8 is the tolerance grade, that is the IT8. Similarly, we have to see the how to represent the fit. So a fit is designated by the basic size common to the hole and shaft followed by the symbols corresponding to each element of the hole is quoted first. Thus, if the basic size is the 50 mm and the hole is the H7 and the shaft is the F8, then fit is designated by 50 H7 F8. So fit is, first we have to write down the basic size. It is the common for the hole as well as the shaft. Then we have to represent the hole. So hole is the H type of the hole and the tolerance grade is the IT7. So next we have to designate the shaft. Here F type of the shaft and tolerance grade is the 8. So fit we are designated by the 50 H7 F8. Next we have to look for the manufacturing process and the IT grade is produced. So here I have to observe the various manufacturing process and its grade produced. So for the lapping and honing processes are produced the IT4 and IT5. So high accuracy applications we have to go for the lapping and honing processes. And cylindrical grinding is produced the IT grade is IT5 to IT7. And surface grinding process and broaching process is for the 5 to 8. And reaming process is the 6 to 10. Turning operation is the 7 to 13. Hot rolling is the 8 to 13. And extrusion process is the 8 to 10. Boring process 8 to 13. Milling process 9 to 13. Planing and shaping process is 10 to 13. And drilling process also 10 to 13. Die casting process is the 12 to 14. Sand casting process is 14 to 16. And finally forging process IT grade is produced IT 14 to IT 16. So next we have to look for the fundamental deviation formulas for the shaft, which is varying the size is up to 500 mm. So in this table you have to observe. So these are all the formulas to determine the fundamental deviation for the various shaft. So here you have to, at least you have to remember the shaft D, E, F and G. So these are the formulas we should have to remember. Next we will discuss the selection of hole and shaft for the various type of the fits. In general, H type of the hole is fixed because H type of hole is having the lower deviation is 0 and its tolerance is varying unilaterally. So hole H is the basic hole. So depend upon the type of fit, we should have to select the various type of the shafts with respect to the hole capital H. So if you require the clearance fit, we should have to vary the shaft is the small a to small h, and if you require the transition fit, we have to select the shaft to j to shaft to n, and if we require the interference fit, we should have to select the shaft size is the p to zc. So this is the standards of the limits, and thank you.